Hello Matrix, welcome to another video, and I will be doing a question 2 today. This is taken from KZN, June 2022. Okay, exams. Okay, that was the common paper. So this was a request by Hassan. Okay, so I hope, Hassan, this is the correct question requested. Otherwise, if not, let me know. All right, I hope also others will stand to benefit from this exercise. So let's just jump into the business. So here we're given in the diagram the question of the circle with center A, okay, is x squared plus y squared minus 2 actually I wanted something here so that it can point. Okay, so yes, x squared plus y squared minus 2x plus 6y equals 15. So this one is expanded, so meaning we need to complete a square here to be able to define the center, or at least to put it in standard form. Okay, the standard form is x squared minus a particular number plus y minus a particular number all squared, equaling a square on the constant on one side, which becomes the radius. Okay, then D is a point on the circle, so we can see where D is. The circle intersects. So once the circle intersects the x-axis, it means these become the x-intercepts. Okay, and we can tell that the corresponding y values are 0 already on the Cartesian plane. All right, so what can we do here? Fine, we already know that basically we can determine the center of the circle and get the coordinates of A, and already by doing so it will also give us the radius of the circle. Okay, so we can safely say that can give us R as well. Okay, or what is it equal to? And then we can also from this determine the x-intercepts by making y 0. So we simply are where we want to be. We can do pretty much the basic stuff in here. Okay, let's move. What are the questions? Calculate the coordinates of the center of the circle A. Okay, like we've been given that this equation of the circle is given by x squared plus y squared minus 2x plus 6y equals 15. Now, what does this imply? So we want to put this one in the standard form for a circle. So this is going to be essentially, we group what looks like, okay, 2x and then plus y squared plus 6y equals 15. All right, then when we complete a square, okay, so here we're going to focus on these two. What we do on the left hand side, we write here x squared minus 2x, okay, then we add. What are we adding? We're going to half the coefficient of x, which is 2. We divide it by 2, and then we square it. Okay, and then we move on and come here. We've got y squared plus 6. Okay, y, and then we add again. We half the coefficient of y, and then we square it. Okay, equals 15. Now what do we do on this side? We take all of these things that we added, and we add them to this side to neutralize what we've done. Okay, this is now 2 divided by 2 squared plus 6 divided by 2 squared. All right, this implies, now what we do, we factorize this thing. Maybe let's do it much closer. So now what do? We take what is under the square, which is x, we take the original sign, and then we take what is under the square here. 2 divided by 2 is 1. And then we square everything, plus, we get to y, we take what is under the square, which is y, take the original sign, and you take what is under the square here. This becomes 6 divided by 2, it's 3, all squared, equals, and then here we just add everything together. 2 squared, sorry, 1 squared is 1 here, so we've got 16. And then here we've got 6 divided by 2, that's 3. 3 squared is 9. 16 plus 9 is 25. Hey, why is my 5 trying to look funny? Okay, so once we have put it in this form, now this is the standard form of a circle, then we can make a conclusion that now therefore center A is given by, now you take the opposite sign of the number inside that bracket, so it becomes 1 is 2, then you take the opposite sign of the number inside that bracket for y, it becomes -3. That becomes the answer. Okay, so that is how one solves this one. It is solving by completing a square. So just know that one. Once it's given in the expanded form, you solve it by completing a square. Okay, that is how you handle that business there. Okay, but again, you're going to focus on x and y separately. Okay, don't make the mistake of trying to combine them instantly. Okay, that's easy. So 4 marks in there, it's pretty easy. So yeah, I guess you're getting 2 marks for these 2 already. And essentially to get to this form, that's a mark already. And then all of these gymnastics that you've performed here of adding and subtracting things is where the 4 marks are. The rest was just pretty rearrangement and organizing what was already given. Okay, now question 2 says determine the coordinates of the x-intercepts of the circle. So now the x-intercept of the circle, it's when y is 0. As you can see, the y value here is 0. Okay, as you can see here, the corresponding y value at B is 0. The corresponding y value at C is 0, read from the origin. Okay, so now if we want the x-intercepts, it's much easier. It's much easier now to take this form that we've just arrived at here, because that form makes life a lot easier. So we can just write here for x-intercept, okay, it is such that y equals 0. Yeah, don't know, when I start talking the throat becomes throaty. Why? I don't know. It's irritating actually. Anyway, so x-intercept, it implies that y is equal to 0. So what does that imply? When we take that equation, we saw that x here minus 1 all squared plus, instead of y now we're going to put 0, plus 3 all squared is equal to 25. Okay, so this is what needs to be done. And then we solve further, getting x minus 1 all squared plus this becomes 9 equals 25. All right, not a problem, which also implies with transpose 9, we get x minus 1 all squared equals 9 minus 25 is 16. And we can tell that these are perfect squares, so we can take the square root sign on each side. When we do that, this one becomes a positive square root, right? Don't make a mistake this side. So it's going to be x minus 1 equals the square root of 16 is going to be plus or minus 4. Okay, great. Now once we get here, we can solve further and say therefore, now remember, it's either x minus 1 is equal to 4 or x minus 1 is equal to minus 4. So let's say x minus 1 equals 4. When you transpose 1, it becomes a 5. So we can say x becomes a 5, or x becomes, if now this x minus 1 is equal to minus 4, when you transpose this, it becomes positive. So minus 4 plus 1 gives us a minus 3. Okay, great. Now let's look at our diagram again. We can see that B is on the negative x-axis, C is on the positive y-axis. So we just look at these numbers and arrange accordingly. So we can say therefore the x-intercepts are such that B is minus 3 is to 0. Let's just write correctly. Okay. And C is the point 5 is to 0. So that's how you solve that. That's the answer. Okay, great stuff. So we're getting 4 marks here. Okay, first of all, substituting y for 0 there is the key point. That's the first mark. And then the second mark is essentially giving these coordinates, but I mean giving the coordinates, already implying them. So I don't know, man, maybe let's do this. Let's say getting these values is important, so 3 marks. And then the 4th mark is essentially the gymnastics performed at this stage, taking the square roots on both sides and solving accordingly. Otherwise, writing them down, we've already sorted them because we said x is 5 or minus 3, and we've already said y is 0. So this is just writing it, you know, for formality's sakes. Okay, determine the equation of the tangent to the circle at D. So if we're looking at our circle, we have point D. So let me just try to show where the tangent is doing the things. So if we draw a line there, I'm just going to sort it, so don't worry about looking, by that thing looking strange. Okay, there it is. So it is a tangent there. Okay, so that is the tangent. I'll just write it 10. Okay, not like this. It's better to write on top of the line than under the line. So I'm just gonna write 10, or maybe we can say tangent. Why not? Okay, so now that we have drawn our tangent, what can we do? Well, we also know that from theory, a tangent, if we consider this a radius, because it's from center to circumference, so the tangent is always perpendicular to radius, right? Yes, so that means AD is perpendicular to the tangent line. Okay, so what do we know about perpendicular lines? We know that the product of their gradients equals -1. So we're going to use that property. And remember, we've just found out A here to be 1 and -3. Okay, so we found the coordinates of A. So we've got 2 points, so we can get the gradient of AD. And then if we divide that from -1, we actually get the gradient of the tangent. So that's the planning that needs to go in there. So we can say safely here, we know that the gradient of the tangent multiplied by the gradient of the radius is equal to -1. How do we know this? It's because we know that the tangent is always perpendicular to radius. Okay? So that's what we know. And then this implies that now the gradient of our tangent into, let's sort the gradient of our radius. We saw that it's going to be AD, okay? Now if you're looking at the coordinates of D, so y is -6, so it's always change of y over x, isn't it? So this is -6 minus -3, it becomes +3 over. Then the next one is going to be, that was 5, right? And then -1, okay, that's what we have, is equal to -1. So this is what you do to make your life a lot easier. Here you can just do the conclusion because you're already familiar with a lot of things as a matriculant. So this becomes -6 plus 3, it's -3, and then 5 minus 1 is 4, so this is -3 over 4. But then when you divide it by -1, then the negatives cancel out, and then the fraction flips, it becomes 4 over 3, okay? So just know that would be the gradient of our tangent. Okay, do I have enough space? It looks like I still do. So now this implies what? It implies that my tangent is such that y is equal to 4 over 3x plus c, isn't it? Which would be the y-intercept. And then we know that through point D, I was trying to write properly. You win, okay, let's leave it as ugly as it is. Point D was 5 is 2 minus 6, right? Right. That would be such that, now we substitute this point onto this line because D is a point that lies on that line as well, okay? So it's a point of contact of both the line and the circle, so they're equal there. So now when you substitute y is -6 equals 4 over 3 into 5 plus c, okay? Now again, the quickest gymnastic you can do, they just multiply 5 by 4, you get 20 over 3. Then you transpose it to the other side, you get -6 minus 20 over 3. Then 3 by 6 is 18. So -18 minus 20, that's -38. Then you divide by 3. So we can say here, therefore, our C is going to be -38 over 3. Therefore, our equation of the tangent, y is going to be equal to 4 over 3 x minus 38 over 3. Okay, that's the answer. Okay, so that is how simple this thing is. So the key statement here was to know this analytical method, okay, because that is the greatest tool ever, and you only start having this in analytical geometry, right? Right. And then of course doing the gradient of the radius, because it was not given, it is important to calculate it, and I can safely say getting the gradient is important. And then substituting into a particular formula is important. Getting the y-intercept is important. and then finding the final equation in the normal form. So that is how those 5 marks are arrived at. Okay, that's great. That is great stuff. So I cannot believe, guys, I've been doing this for 20 minutes. This is ridiculous. How can time fly like that? Or am I too relaxed? Maybe. Determine the area of ABC. Okay, area of triangle ABC. Where is triangle ABC? Well, we can see that triangle ABC is formed by joining this point to the circumference and joining that point also to the circumference, the radius essentially. So this gives us triangle ABC. Okay, let's staple it so that someone can see it, or maybe we can just complete the triangle instead. Okay, maybe let's staple it to accentuate. Is it accentuate? Its visibility. So that's the triangle we're talking about. Now, what can we do about this triangle? We've worked out coordinates of B. We got -3 and 0. And then we got the coordinates of C. We got 5 and 0. So since BC is a horizontal line along the x-axis, we can easily determine its size by taking the x-coordinate here minus the x-coordinate there, because the y's are 0. So from the distance formula, that falls away. But then we know that we can actually look for the height of this thing. Okay, the height, if we consider BC as the base, it will become perpendicular to the base, isn't it? The height is from the basal side to the other apex or vertex. All right, so we can call it H. Now, what would be the size of H? You can already see that the size of H is basically the distance of point A from the x-axis, and that is determined by its y-coordinate. Of course, you forget now the sign. It will just be 3 units. Okay, so now we've got H, which is 3 units. We can work out BC by just using the x values in those 2 points, taking their difference. Now we have set up our area as you calculate an area in grade 6, is it? Yeah, half base times height is stuff you do in grade 6 even. Okay, so we can say here safely without wasting any time. We can just say let H be the height, of triangle ABC. Okay, great, because this is something we introduced. It was not there. So you always, once you introduce something that was not included, you state it, isn't it? It's like when you have money that you've earned in a particular way that is not standard, you have to declare it. Or we will say tomorrow when there's an investigation that you stole it because we never knew about it, isn't it? Yes. Now I can safely say you copied if you don't have a plan, because it means you don't understand what you are doing. Anyway, area of triangle ABC is going to be equal to half the basal side. We're going to take BC times H, the perpendicular height we just introduced. Then this is going to be equal to half into BC is going to be 5 minus 3. It becomes plus 3. It's a horizontal line, so you just take the difference of those x values. And then into H, H we said is going to be the distance of point A from the x-axis, because that is a vertical distance. So it is 3 units. So you forget about the sign. Okay, now this is 8 times 3, that's 24. Divide by 2, that is 12 square units. Okay, that's the answer. All right, so that is easy, guys. So it's pretty simple here. We just are going to get a mark for determining those two values because these values were not quite obvious. And then of course the answer together with the units. Do not forget the units, they're important. The formula in maths is not something you really get a mark for. Okay, 2.5 says, given another circle, this circle is x minus 1 all squared plus y minus b. I'm sure they forgot a square here. Otherwise, it's not a circle, isn't it? Yeah. We can't have this form if it is a circle and then there's no square here. So I'm pretty sure there must have been a square or a 2 that was left there. Okay, so because this would determine the coordinates of the center and this would give us the radius of the circle. So we are told this one touches this circle with center A at only one point only. Okay, then it says give one possible value of B. Okay, so let's get the one possible value of B. Great. Now what do we do here? First of all, we can say we know that from what we've been given. Okay, in fact, let's just say let's start by introducing stuff. We can just say here let the center of new circle be, say, Q. Okay, you can pick any letter. You just let it be Q. We can say therefore Q would be the point. Now you take the opposite of what is under the square there. The number is 1 is 2. Then here you're just going to take the opposite sign of B. Whatever B is, we really don't care. That is how we understand an equation of a circle. But now, of note, do you realize that the x-coordinate of our circle, the new circle, is the same as the x-coordinate of our circle with center A? So this means this circle here, this new circle with center Q as we decided, is certainly along the line that passes vertically through the center of this circle. So if we're to extend this, maybe let's choose another color here. If now we are to extend this, okay, maybe let's do it a straight line and then we break it apart. So if we're to, sorry, if we're to extend this line all right through, so okay, maybe I need a bit more working space here. Alright guys, so I'm just extending this line so that it can give us some working space. So we can just break this line apart to such as that it's not really a real line, but it's just our way of getting stuff done. Now, this means our circle has the x-coordinate that is the same, meaning it lies either vertically below the center. It means it lies vertically below point A. So now we can draw our circle here and say, fine, this circle should be something like, let's choose this one. It could be something like this. I mean, it has a small radius. Or it could be something like that. Right. It has a small radius, so if no one more, I don't know why that circle actually didn't sit right. Let's try again. Say this circle here must too can be something like that. Anyway, just forget about how they intersect at this point. It's starting to give me a heartache. So let's say the center of this circle is there or here. So we said the center will become center Q. So Q can be there, can be here, it doesn't matter. So this means this circle is like that. And then of course, it means also that the radius of that circle, because we were given the fact that it is 1. So when you take the square root of 1, it's just 1 unit. Okay guys, I'm going to try to move a bit quicker. Sorry for showing too much time. So this is 1 unit. Okay. But what is this one? This one is 5 units, the square root of 25. Okay, so that's understandable. Okay, so now what do we do? Now when circles touch each other, it means the distance between their radii is actually the sum of the radii. Okay, that's the understanding. So we can say this is RA, then we can call that one RQ, meaning the radius of circle Q. So now we want to decide, how do we solve this? We're saying, obviously, the distance between these two will be their radii added together, as you can see. Not a big deal. Don't know why these things are making noise here. So basically, we know that if if the two circles touch, okay, at one point, it is such that, or it implies that now we can say AQ is equal to RA plus RQ, because it means the circle center. Yeah, but the other RQ looks crazy, né? So yes, so meaning the radius of the circle center A, not minus but plus, okay, because it is the distance between them, which is essentially their radii. That is how you explain a story like that, okay? But now you're going to need the distance formulas, isn't it? So this implies AQ, we definitely have to use the distance formula, but the distance formula won't necessarily help us. Why? Because this is a vertical line. We know that this is perpendicular like this. So this is essentially a perpendicular line. So it is defined by only the y values, but you can use the distance. Maybe let's just be, comprehensive for just one moment instead of taking too many shortcuts. So we can use that distance formula here and say this implies that the square root of x at, say, q minus x at a squared plus y at q minus y at a, or squared, is going to be equal to these ones added together. We can see that the radius here was 5, and then the radius on the other one is 1. Okay, so I don't know why I'm not writing it hypothetically so that we can substitute all at once. So this is R, A, R, Q. All right, which also implies now we substitute. Now when we substitute here, this is going to be x at q is 0, is 1, isn't it? Minus x at a is 1. So do you see why this one disappears? Exactly. And then we get to this one. This becomes b, isn't it? Minus, this one was a minus 3, so minus 3, it becomes a plus 3. all squared equals, that radius is the square root of 25, which is 5, plus the square root of 1 there, which is just 1. Okay, we solve further, but now we see that 0 falls away. Okay, we have the square root here of b plus 3 all squared equals 6. Now you can see that when you're taking a square root of a square, these two cancel, isn't it? Therefore, b plus 3 is equal to 6, because we didn't do anything on that side. Therefore, b, you transpose the 3, 6 minus 3 is just 3. And it makes sense, isn't it? Because if b is positive, definitely it fits into the picture, because this needed to be a positive number, at least for it to make sense. Not a problem. So that is how we answer this question. Okay, guys, I think I've taken more than I am supposed to take, but it's okay, it's all right. So I think this is important, because if you don't notice it, you are dead, certainly dead. And then the second thing here is correct substitutions here, and is the answer. So we've got 3 marks. So where else do we give you the marks? I don't know, man, there's just too many areas. So let's just say the gymnastics here to try and stay away from causing problems. Okay, the last question says, does point P lie inside or outside the circle centered at A? Justify your answer. Well, the answer is, let's find out. Let's find out. So all we know is that if point P lies on the circle, so let's say, for example, because we're given that this is 1, so let's just say point P lies here. What is that? Yeah, they said P, but they said -1. No. So let's check. -1 would be on the other side. So if this is 1, yeah, this diagram was crazy, was it not? Definitely crazy. So -1 is here, but they said -1, -7. So we can say, let's say for example, we're looking at point P being here at -1 is to -7. For it to be at circumference, it means the distance between that point and the center should give us the radius, which is 5 units. Okay, if it is inside, if point P by any chance is a point on the inside, what am I doing now? If point P is somehow here, say that is point P, which is still -1 is to -7, it means the distance of AP should be smaller than the radius. Okay, that is what it means. And then if point P is a point outside, say it's here, so it means the distance AP should be greater than 5. So meaning you have to consider these possibilities of the positions of point P and try to understand exactly what are you going to get, which suggests which one of these is the case. Okay, so let's go on. So we're just going to find OP. If OP is equal to the radius of that circle, then it is on that circle. But if AP is less than the radius of that circle, it means it is inside that circle. If AP is greater than the radius, it means AP is outside that circle. Sorry, so let's just say, what is AP? Because that is what can give us an answer. This is going to be the square root of x at P minus x at A all squared plus y at P minus y at A all squared. Okay, great. Then we substitute. So now when we substitute, what was x at P? It's minus 1 minus 1, okay? Because point A is 1. All squared plus, sort this one out, it's going to be minus 7 minus 3 is going to be plus 3 all squared, okay? Great stuff. And then let's move on. What is the story? What is the story? What is the story? Now let's see. This is basically going to be the square root of what? Minus 1 is 2. Minus 2 squared is 4. This is going to be 4. 4 plus 4 is 9. So that is 20. Okay? So I'm getting 20 there. Okay? 20. Now, that is the square root of 20, which when we sort it out, it could be 2 root 5. Okay? Always try to rationalize, or should we say simplify further. 20 is basically 4 times 2. Sorry, 4 times 5. Then the square root of 4 is a 2, and then you remain with 5. Okay? I'm sure you know what to do here. So now 2 root 5 is definitely smaller than the radius. Where's my calculator? I don't know where's my calculator. That's why I'm struggling. Now I can't guess this one, unfortunately. But I know it should be smaller than 5. Okay, so let's just check, but I'm sure square root of 5 is going to be 2 point some change. Right, yes, 2.3 basically. And then we multiply that by 2, we're getting 4.5. So this is basically, which is less than the radius of circle A, okay? So if it is that case, therefore P lies inside circle center A, okay? So that is how you answer a question like that, and we are happy. We are exceptionally happy, Papa. The other thing that you could have done here, sometimes there's more than one route you can answer this. So if you think about it, you just take that equation and substitute this point. So remember the equation was x minus 1 squared plus y plus 3 squared equals 25. You just substitute that point in, and then you get minus 1 here, all squared, and then here you get minus 7 plus 3 all squared equals 25. Solve this. This is 4 plus this one is 9. Sorry, what am I saying? It's a lie. It's 16. Okay, equals 25. This is now 20. You can tell that 20 is not equal to 25, isn't it? 20 is less than 25. So by the mere fact that this is small, it already tells you that circle, that point is inside that circle, meaning point P is more likely to be here or anywhere inside this circle, but not at circumference, as in here, and not outside that circle. Okay guys, I hope you liked the video. Took a bit longer than I expected, but you saw how I reasoned through some of the important steps. Otherwise, see you next time. Bye-bye.